I'd like to talk about our paper, which is recently published in ApJ. So our paper is mainly focusing on the one mystery in gamma ray bursts. That is, the question is, why are some gamma ray bursts hosted by oxygen-rich galaxies? Okay, let's move on the introduction of my paper. So this is a simple imaginary picture of gamma ray burst, long gamma ray burst. So people believe that the long gamma ray burst is related to the death of fast rotating massive star or something like this. So this fast rotating is quite important for massive stars to launch a relativistic jet, this strong jet. If we observe along this jet axis, this object, we can recognize this object as a gamma ray burst. So in this sense, our launch of relativistic jet and fast rotation is quite important. In the theories, GRB theories, low iron abundance, so for example, the only 10% of solar values is important because iron abundance drives a strong stellar wind which takes a rotating angular momentum away. So if iron abundance is very high, so stellar wind becomes very strong, so which result in slowly rotating massive star. So in this kind of object, they cannot become gamma ray burst anymore. So in this sense, theoretically, so low iron abundance is very important for massive stars to become a gamma ray burst. So one way to investigate this kind of metallicity environment of gamma ray burst is observation of host galaxy of gamma ray burst. So this is one example of spectrum of host galaxy of gamma ray burst. So people usually use oxygen abundance in observations. They use oxygen abundance as an indicator of iron abundance environment of gamma ray burst. So there is one mystery here. So somehow some gamma ray bursts are hosted by high oxygen abundance galaxies. This is almost approaching to the solar value. So this value is almost one order of magnitude higher than theoretical predictions if the oxygen abundance is a good indicator of iron abundance. So, but it is not necessary for oxygen abundance to be exactly same as iron abundance environment. So in this sense, so iron abundance measurement is very important to investigate physical mechanism of gamma ray burst rather than oxygen abundance. So, but there is problem here because the emission line from iron is usually very weak observationally. So in order to overcome this problem, we use optical large telescope, spiral telescope, to observe one host galaxy, GRB host galaxies. And also we use spectra taken by BLT force 2 for other host galaxies. So actually, one of two, this host galaxy shows very high oxygen abundance. So for these two targets, we did iron abundance measurement. So this is one example of spectra taken by spiral telescope. Actually, we successfully detected emission line very weak, but we detected emission line from iron here. And then we can estimate iron abundance from the flux of this emission line. Okay. Then, in order to figure out the metallicity environment of host galaxies, we collected a reference sample from Sloan Digital Sky Survey. So this is y-axis oxygen abundance as a function of stellar mass of star-forming galaxies. So normal star-forming galaxies in Sloan Digital Sky Survey distribute like these contours. So among them, we selected galaxies for which iron abundance are already measured. So these guys are plotted by the black dot here. So we used these galaxies as a reference sample, which is compared to gamma ray burst host galaxies. So the point here is that our reference sample is basically biased toward low metallicity compared with the normal star-forming galaxies. Okay. So this is final important figure in my talk. This is the iron abundance in y-axis as a function of oxygen abundance. So actually, our reference sample here, black dots, actually show low metallicity, bias toward low metallicity. And colored dots is taken from the gamma ray burst of the galaxies. So actually, we found that gamma ray burst of the galaxies is almost comparable to our reference sample, or still lower than reference sample in terms of iron abundance. So this suggests that gamma ray bursts probably prefer the low iron abundance environment, regardless of the oxygen abundance value, because actually one of them, of our sample, shows actually quite a high oxygen abundance. In spite of a high abundance of oxygen, so actually iron abundance shows very small, which is consistent, which can be explained by theoretical prediction. Okay, this is summary of my paper. So the mystery in gamma ray burst is that some galaxies are hosted by oxygen-rich, some gamma ray bursts are hosted by oxygen-rich galaxies. So we for the first time compared oxygen abundance and iron abundance based on all the gamma ray bursts of the galaxies, based on emission line diagnostics. And then we found that regardless of value of oxygen abundance, so iron abundance of GRB host galaxies shows very small value. Iron abundance is very small, which is consistent with theoretical prediction. So this suggests that oxygen abundance is not a good indicator anymore, so we should use iron abundance in order to investigate physical mechanisms of gamma ray bursts.